5.2, verifying trigonometric identities. When you are verifying trig identities, you have to remember that there is no well-defined set of rules to follow in verifying these identities. The process is just best learned through practice. There's lots of different avenues you can take to get to the correct answer. It's a useful process when you need to convert a trig expression into a form that is more useful algebraically. You can find these guidelines on page 348 in your book. Here, we're gonna go over these guidelines for trig identities. Let's see if I can zoom in. All right, there we go. You can follow along in your book if you want. All right. The first step is to work with one side of the equation at a time. It is better to work with the more complicated side first. Right? Next, look for opportunities to factor an expression. Okay, factoring is always a way to simplify it as well. Add fractions. Okay, if you want to add a fraction, you need a common denominator. You can square a binomial or create a monomial denominator. Look for opportunities to use the fundamental identities, like transform tangent into sine over cosine, transform sine squared into 1 minus cosine squared. Note which functions are in the final expression you want. Sines and cosines pair up well, as do secants and tangents, and cosecants and cotangents. When the preceding guidelines do not help, try converting all terms to sines and cosines. That's like the basic form, right? Everything can be made up of sines and cosines. So if nothing else works, just simplify it or transform it all to sines and cosines. Always try something, all right? You may not know exactly how you're going to get where you're going, but just start. Just start walking and you'll get somewhere. Start playing around with it. Start doing something. And here it says if it leads to a dead end, then even that can provide insight. Okay, start again. Verifying trig identities is a useful process when you need to convert. Oh, I already said that. Sorry, I'm just reading this off here. When verifying an identity, you can't use operations such as adding the same quantity to each side of the equation like you can with solving an equation, because you're not sure that that equation actually is equal and balanced, so you can't start adding things to both sides. You have to work with just one side of your equation at a time. Okay, zooming back out. All right, let's practice with this example number 1. We have secant squared theta minus 1 over secant squared theta equals sine squared theta. And we need to verify this identity, which means just prove that this is true. Very similar to what we were already doing in class. So we're going to work with one side and prove that this is the same as this. So there's no answer here. I'm not looking for an answer. I'm actually looking for the process. The process is the answer. All right, so from your identities, this looks familiar, right? Secant squared minus 1. That should look familiar. The sheet that I gave you had all of the identities also kind of transformed, moved around. So we have this identity here. This is on page 348 of your book. This identity, 1 plus tangent squared equals secant squared. On your sheet that I gave you, it has this also worked out to where it says tangent squared equals secant squared minus 1, and then 1 equals secant squared minus tangent squared. So let me just write that off to the side. Oh, sorry, forgot to zoom back out. Let's see. All right, so because we know this is true, then we also know that, sorry, this is sloppy over here. This is true. Tangent squared equals secant squared minus 1. So that's what we have right here. So we can change that on the top to say tangent squared. We're just going to work with this side. You don't have to keep writing this. We're just going to work with this until it becomes that. Sorry, give me a second, I lost my page. All right, now we can change this. We can go ahead, I'm going to go ahead and change everything to sines and cosines. That's kind of my go-to. I like to work with that. So we know that tangent squared is sine squared over cosine. And secant squared is 1 over cosine squared. When you divide, it's the same as multiplying by the reciprocal. I'm going to go ahead and do that in one big step. If you need to write it all out, that's okay. So instead of this divided by this, we have this times the reciprocal. And then these cancel, and you're left with, yay, sine squared theta. So now the two sides are equal, and we've verified that identity.